So I was sent with a message from Dan Lenahan,
Right.
which is, this needs to happen. He wants this to happen. The cardio-oncology group at Washington University is behind this, and they will do whatever you want.
Well, that's really reassuring. And I want to make a pitch for what you just mentioned. First of all, WashU, a great institution with a lot of people that are thinking out of the box. And the other thing is that we have cardio-oncology as a robust network now at the American College. And I'm one of the leaders of JAC, Journal of American College of Cardiology. We just initiated the new journal. So it could be a journal where we house a lot of our plans. We can actually publish proceedings from a meeting like this there, and then have the support of the editorial board.
We need input from you as well. You meaning the audience.
So in terms of trying to operationalize this, is this a clinical trial data logging machinery that you would envision as the backbone of this, or a more data dictionary driven, at every follow-up, these are the things that we are going to collect,
Yeah.
and the group deciding what are the components that are very critical?
Yeah.
What would be the approach?
I think as a registry, first of all, I think the clinical trials will come later. But if you design it so that you have in mind, because if we design clinical trials, we're going to sideline ourselves. We need the registry first. We need to document in an observational way, characterize these patients, characterize follow-up, and we should harmonize it. It should be harmonized. So our definitions of complications, of bleeding, and so on, all of that could be harmonized. And we have ways to do that. I think if we collect the data in a single way, in a singular way, then we can have the ability to characterize the patients more harmoniously.
So just want to call your attention to an effort that is currently being backed by ASCO, is the MCODE effort. It's a minimal common oncology data element initiative, primarily designed for national and international integration of data regarding exposure to agents and treatment outcomes from them. The implementation guide on that is already published and available. It is free.
Great.
So if we can all adopt the same standard,
Yeah.
it has multiple advantages. Even if we, due to logistical or funding issues or other reasons,
Yeah.
cannot use the same exact platform,
Yeah.
the fundamental structure of the data remains uniform
That's
across.
fantastic.
So it would be, even if it is a distributed model, like your center doesn't have the funding to
Yeah.
subscribe to a platform to enter data into it, if the structure is the same, at the back end we can integrate when
Yeah.
a hypothesis is put forward, you can then integrate and...
It's a great idea. We've actually done this in Toronto because we have a citywide, university-wide cardiovascular surgical registry, and we've used that data. The big challenge was double data entry, right? So they were entering into the Toronto database, then entering into the STS database, and it got out of control. And the promise we made was that we'd have one data entry and then we could populate different databases. So there will be other, ASCO may have a database that we want to populate. We would our governance would say, yes, we want to participate in that. I think that's the model, so, yes.
So I just think this is wonderful, and I loved your talk too. Sorry, but this is I think it's important since everybody sees this from their seat. So medical oncologists see this one way, radiation oncologists
Yeah.
see it another way. My cardio-oncologists see it a whole different way, and the surgeons are going to see it a completely different way. That your governance board makes sure that it has equal
Yeah.
representation amongst all of us.
Yeah, absolutely.
Otherwise, you're going to end up with an
Yeah.
unuseful registry in the big
Yeah.
picture.
We have a registry, a large international registry of dilated cardiomyopathy, which is very common. 1,000 centers will be involved. It's based on an MRI database linkage to the cloud. But we have different committees. We have an electrophysiology committee. That's how we started. We tried to predict who needs to have an AICD. That's how the whole registry started, with that one question. A little different than this particular registry, but we have a heart failure group. We have an imaging group. And I would say that each of those groups should come forward. That's also a way to have leadership at the national meetings when ASCO meets or American Heart meets, or cardio-oncology group. We have representation. So that would be part of the governance, and having these working groups would be vital.
I think that's right, Brian, because I mentioned the retroperitoneal sarcoma initiative earlier on, and even though that's clearly dominated by surgeons, Alex has still involved other disciplines, so radiation oncology, medical oncologists, radiologists, and pathologists. And I think the way that they, as I mentioned earlier on, the way that they've been able to retrospectively collect data has really sort of better defined those different diseases rather than just quote unquote retroperitoneal sarcomas, and that's actually informed the design of the new EORTC randomized trials. So it's definitely possible.
Yeah. I think that you have to build on a very strong foundation. So that initial governance and model and how it's rolled out will really need to be very robust. But if it is an inclusive, I always say if you have to be inclusive, don't leave anybody behind. That's the key from the beginning, and I think that's the philosophy we have with this registry.
Will the registry support raw imaging data, or just reports of imaging data?
You mean you have raw data that you could? I didn't get the first one.
Would it actually include imaging data directly, or just reports of imaging data?
Oh yeah, well that's a good point. I mean, the way that we're doing the cardiomyopathy registry, we have all the images downloaded in red, central reading. I think in this case, I would vote for that as well. You could have the reports, certainly, and we would have that. But I think if you had an imaging core lab, there's no reason we couldn't do that. We have the ability to download MRI images and other caths and so on. We have that technology now. So I would vote for that.
So the question for Dr. Schultz, is there any role for cardiac gating in the radiation therapy?
Potentially, yes. That would be the next level of sophistication, I think. I haven't heard of that being done, but I don't see why not.
And do you ever modulate the radiation dose within the tumor volume?
Yes. We sometimes will boost one particular part of it, for example. Oftentimes what we irradiate is not just the tumor, but some of the grossly normal appearing surrounding tissue. And so sometimes we'll have what we call an integrated boost, where more radiation will be in the part where the gross tumor is and less radiation will be in the part that we're more trying to sterilize.
Question for Dave. Where does newer platforms such as tomotherapy, say proton beam, or even SBRT sits?
So SBRT is already being used. For example, the technique that was used for the patients with ventricular tachycardia was actually using SBRT.
Can you just define that for people who don't know what SBRT is?
Stereotactic body radiotherapy, meaning the delivery of highly conformal, high-dose radiotherapy in very few fractions to a small area. So that was using SBRT, of course not for a tumor, but for another structural problem. Tomotherapy is more of a different technology. It does deliver radiation in a different way, but it doesn't necessarily, at least as far as I'm concerned, offer huge advantages in this context. It's very useful for some things, but I'm not sure it would be more useful than what we have available generally, volume modulated arc therapy for cardiac tumors. Proton therapy probably does have a potential role in the treatment of cardiac tumors. The real advantage of proton therapy is that you can avoid radiation to structures that are very close to one another. So if you're trying to target something which is very close to something that you're trying to avoid radiation to, protons are great for that. Now the heart would be very tricky because the image guidance associated with proton radiotherapy is not very good at this point, or not as good as it is for other modalities. The heart's moving, and in the case of the heart, there aren't small finite structures that we know we should avoid. Now I should say some things like the sinoatrial node, for example, is very sensitive to high-dose perfraction radiotherapy, and we know that because in some instances, for example, people have radiated lung tumors that were very close to that with high-dose perfraction radiotherapy, and that patient later developed six-sinus syndrome. So there are structures that are highly sensitive to high-dose perfraction radiotherapy, but we don't know that they are what they are yet because we haven't used that modality widely or for cardiac tumors very much yet. But as we do, we'll discover other sensitivities like that or other sensitive structures, and we'll know better what we need to avoid, and that may be when proton radiotherapy has a more of a role.
Thanks. I think the next question that I have, if I may, is directed at RJ as well as Dr. Farouk. I think there is another component that is yet to come, Abbas talk on CanSarc. So I think within the Toronto Sarcoma program, I'm talking at least for myself and hopefully for the group, we are extremely enthusiastic about this. We want to make sure that we can synergize what has Abbas set up for this sarcoma program nationally into this international registry. The bit that I would also urge is for us to indicate if there are samples available, because I think we don't even have to have a centralized bank for this registry, but even if we can identify if there is tissue or even like a block number, so you can constantly know how many patients you get access tissues to as we build this along. The other comment I have is that I think before the sun sets today, we really should come up with an action plan how we're gonna take the next steps, because I think whilst this is hot, we should really strike it. And whilst we have our guests here, who I would imagine would be one of who would be the vanguard centers as well as we develop these registries, we should really come up with our next steps in our strategy for the database.
I'm very, very lucky to live in Toronto. Very lucky to be a staff surgeon here at University Health Network, because as you've seen today, there's 2 people already that you've seen, and Albie, you're not included, but you're a 3rd person, and Abba's a 4th person. And everybody around me in this place is world class. And this is an idea, I knew that he was here, Dr. Farku was here, and I know he's an international reputation in doing these things. So I approached him about this, and he's taken it and he's run. And the next step is going to be get the thing going. And I think that's absolutely correct. I've spoken to friends in India. I've gotten buy-in from India. I've gotten buy-in from China. Buy-in from the United States, buy-in from Canada, and we have to get buy-in from many centers. We have to sit down, as you said, while it's hot and get things going. So I think it's a wonderful idea. I've had this in my mind for a long time, not just for sarcomas. I hate to say this to everybody, but even the fibroblastomas. As a surgeon, I send a patient who's got this little thing flipping on the aortic valve. And I asked the questions. I was going to have a whole cardiac tumor meeting on fibroblastoma, what to do about it. And I asked Mike Reardon down in the States, he goes, what are you talking about, RJ? You just take it out. There's no question, but there actually is a question, because I have another patient who's had it known for 8 years. Do you still take it out? So it's got to be a comprehensive thing. We're talking about what we want in it. We have to sit down with everybody, get everybody to throw into the pot, and make the most robust, cheap database that we can. It's a start. It's a start to get everybody in the world together to do something that everybody in the world wants to do. And I think that's where we start. That's what I wanted to say. Michael?
No, I would agree with that, and I agree completely that, as I said, you build the cement and the foundation needs to be very strong.
Yeah.
So there has to be I would say we usually start with a survey of centers, who's interested, and not everybody can sign up right away, but there should be no reason why, from an operational perspective, we can't get everyone on board. It may be just that people don't see many tumors, and site may decide not to enroll.
But once we get the thing going, we may actually find more tumors than we think.
I'm sure of that. RJ. I think that's what we're gonna. When talking to some of the centers in other parts of the world, the issue of the biobanking is a really important one. The shipping of genetic materials across borders is not so easy, particularly China. We face that, but there's no reason why we can't have regional biobanking. And some sharing of the pathology specimens to look at tissue. I would look at genomics. I'd look at some proteome. We can build that in. The problem in all of these endeavors is if you try to do too much too quickly, it collapses. So I think the first thing is to be inclusive, that everyone feels part of this. We don't want competing groups. If we go to a funding agency, we all go together. If somebody's in Australia, they're the PIs in Australia, they're the leads, and go to their national funding agency. And NIH, it's people like Mike and, we're lucky at NIH, they allow Canadians to go as PIs too. It could be Mike and RJ, for example, at NIH. In Canada, RJ might say another Canadian could lead in the CIHR grant. I think that's how you do it. But it has to start with the simplest, easiest approach. Then everybody sees the win-win and they don't get overwhelmed. But the biobanking could be the real winner here in this particular disease.
This will be our database. Means everybody who's interested in this project. It's not mine, it's not his, not yours, it's ours. Everybody is going to be one family.
We're not interested in everything coming from here, and RJ's the lead. He'll tell you. I mean, read publishing. There'll be papers coming out that we're not even on, perhaps. It's a working group. That's the way. That's the victory you have.
Remember the vision. The vision of the meeting is to improve cardiac care for people with cardiac tumors.
So, there's also some neat things that have happened within the sarcoma community, and I think some of this may help get around your international barriers. So, for the Threshold clinical trial, there was a committee set up of 4 pathologists that reviewed all the pathology.
Yeah.
Remotely, all by camera.
Yeah, it's amazing.
Which means you can get across all of this. And so, that's the group of people missing from this room right now.
Yeah, the pathologists are going to be critical. Yeah.
But this is already established.
Here we go. We have 2 pathologists.
Stand
from
up.
From
the voice. No, but I mean, this is key.
Yeah, it's part of the leadership.
Because there's an intimal sarcoma, apparently in Toulouse is probably, I read the paper, it's probably an angiosarcoma. So, I mean, this is going to matter.
Yeah, that's
And I think
MD
Anderson has been central to this.
Yeah.
If you're doing biobanks, then you need us involved because we're the custodians.
Exactly.
The comment was if we need biobanks, we have to involve pathologists because they're the custodians of the tissue. It's absolutely correct. Just because there's no pathologists on the meeting this year, and I mean this honestly, it does not mean that I don't value pathologists. I've been a friend of pathologists ever since when I was in medical school, actually.
I can fix that.
Same with radiologists as well.
Yeah.
Very important to get the correct diagnosis too. And if you're dealing with a small
Use the microphone. So it's.
Let's give a microphone.
Very important to get the correct diagnosis too. If you're dealing with a center of people that don't see cardiac tumors,
right.
Some of my colleagues say there are 2 cardiac tumors: angiosarcoma and myxoma.
Right.
I think everyone in this room knows that that's a little simplified.
Right.
So when you're dealing with that as a knowledge base, you want someone that actually has seen these and can work up a sarcoma. It's going to be so critically important in precision medicine that we actually get the diagnosis correct. Otherwise, we're doing a disservice to our patients. And having the correct diagnosis for a registry, and if you want to start talking about microarrays and doing interesting things in biobanking, then you not only need us, we're essential because we are the custodians of the tissue, and you're not getting it without us.
And that brings it to the other reinforcement of part of the mission is to create centers of excellence. And centers of excellence doesn't mean in the middle of deepest, darkest Africa. I don't mean Africa in to point them out, but it could be within Canada, within the United States. Even within Toronto, you need centers of excellence in the country and in each area. We need centers of excellence to help the whole process go forward.
One of the ways we've started these initiatives is also that every site has a lead cardiologist, cardio-oncology person, cardiovascular surgeon, a pathologist, a radiologist. They have a team. And then what happens is when people go to the national meetings, all the radiology folks involved will have a meeting there, and they'll talk about, and the pathologists will have a meeting, and it's really great, actually. It works. But it's just, you've got to bring everyone on board, and I think that's going to be the initiative early on, is to be as inclusive as possible. And I know we've got great ideas today that I wouldn't have thought about.
Yeah, that's great. Michael?
Just to quickly loop back to the biobanking thing, as both a biobanker and a pathologist, I think the virtual biobank, which was touched on, is the right solution. First off, it's inexpensive, but just by keeping a record of who has what accurately is a great first step. And then ignoring legislative issues, there's a lot of institutional ownership challenges, and I'm understating that by several orders of magnitude. So the advantage of waiting until you have a reason is very compelling for an institution to get involved. sure, digital slides de-identified, people are usually willing to share if you have a local investigator taking ownership. You are quite right, genetic material is very complicated since it is by definition secondarily identifiable. So you in general need consent. So, any center with any volume would definitely need a local pathologist. And the advantage is you're not talking about massive volumes of tumors. When breast cancer tried to do this, it was less successful because trying to annotate every single breast cancer case would tick people off. I think here you definitely have the opportunity to record it all.
That's great. You have a few more minutes. I'm going to ask Dr. Schultz a question. You didn't discuss brachytherapy. Some of these giant tumors that you saw, the one that you showed, the angiosarcoma, we stick needles into them. I never thought I could stick a needle into one of those things until I spoke to one of our radiologists about getting a biopsy, percutaneous biopsy, transcutaneous biopsy. What about brachytherapy in these things? Or brachytherapy in general? We'll see whether, what did you say? It's a believer?
Oh, yeah, the agnostic.
Agnostic, believer, and skeptic. Which house do you fall into?
Well, I'm a believer, always with radiotherapy. I can't see why not.
Has it been used?
For cardiac tumors?
Yes.
I've not personally heard of that. It's used for bronchial tumors. It's used for esophageal tumors. So it's quite feasible. The very nice thing about brachytherapy, as opposed to other forms of radiotherapy, is that you have a very high dose, and the dose fall off around that source is very rapid. So it's another way. It was the original way of delivering stereotactic radiotherapy, essentially. And so you can, like we were discussing previously, avoid high radiation doses to adjacent structures. Now, the disadvantage is one and the same, that the dose is very high. So if, given we don't have much experience with it, there could potentially be toxicities, and it would need to be done in the context of a clinical trial.
Any more questions? Comments? How about, you want to say anything? Use the microphone. What?
I mean, do you want me to just, carry on the discussion?
We're supposed to have a little break. What do people think? Should we just carry on with Abba's talk? While it's hot. So why don't we we'll just have them, you have to go, right? When do you have to go?
It's 3 p.m.
3 p.m., okay. So why don't we just have, Mike, you have to go now, right?
Yeah, I'll stay for a few moments. I want to hear this.
All right.
But I'll try to stay as long as I can.
I want to thank,
I just want to make a point, RJ, that at the national meetings, we're going to have, we'll organize some meetings at the surgical, pathology, AHA, CCC, whatever conferences to get people. It'll be a nice way to keep, to float this out to the rank and file. So we'll be sending out a survey to everyone, RJ, and
yeah, that's great. And
be as inclusive as we can.
And I want to thank you, Michael, for your cooperation and for meeting.
Great. I can't think of a field that's in need of this more than this is. So exciting, and look forward to meeting.